Good afternoon, everyone. I'm Sairam and I represent XRX team. We are solving the problem of ID 1614 named Publication Summary Generator. In this problem, we try to fetch and consolidate publication records in bulk. The publication record is a research paper's metadata which has the following data: title, venue, year, URL, and list of co-authors. We retrieve this publication data from DBLP and Google Scholar. DBLP is a dataset which allows us to fetch all the publication records we need in time. So when you search for an author's name, for example, Aishwarya, the front end will request the search author API to get the list of authors, like so. The resulting API call is shown to the user as a dropdown. When a user selects an author from a dropdown, it will result in a customized query call which returns a list of publications related to the author. For example, Aishwarya N. Reganti. The summary is also generated automatically and is shown with the result. We use the APIs are implemented as polling APIs, which allows us to request for a status update. In order to reduce the number of endpoints, we have merged the status and result endpoints as one endpoint. The system is extendable due to the microservice architecture, and based on the needs, any source can be plugged into the current system to produce results from any given source. We use Mistral AI for generating the summary of the author or list of authors, which will be shown later. The main feature of this app is to get the publication details of authors in bulk. For example, we can upload an Excel file containing the author name and type of publication we need to fetch. Let us wait for to fetch. The returned API contains the author name, the title, the venue in which the paper was published, and the year, as well as a summary of the given authors. The summary is generated using Mistral AI's model named Mistral Nemo. We can now download the details as an Excel file, as shown above. Let us now look into backend. The backend is an engine server running Fast API service. The Fast API service handles the endpoints and delegates the task to two workers, namely DBLP worker and the AI worker. The DBLP worker handles the fetching and processing of requests to DBLP, ensuring seamless service to the backend. The DBLP worker is a salary worker, which means that any number of these workers can be spawned based on their needs and their requirements. Now let us look into the AI worker. The AI worker is also a salary worker, which means that this worker can also be horizontally scaled to handle the loads as much as possible. The salary is a task scheduling library, which means that we have the ability to parallelize the execution, ensuring balanced loads across all the servers we have. The workers and the server are orchestrated with the help of Redis, which is an in-memory database to save the result and the inputs of the task. This sort of implementation allows us to efficiently distribute the loads across our servers. Thank you.